right, here we are, sample problem 2F. This is the last of the major concepts in Chapter 2. With this problem, we got a guy serving a volleyball. He's not projecting it across the net. He's just hitting it straight up in the air because we're still talking about motion in one dimension, which is like train tracks. So this goes straight up and comes straight back down and hits the ground. This person hits it with an initial velocity of 6 meters per second here. And some might be asking, well, what's the weight of the ball? And that doesn't matter. It's just the initial speed is 6 meters per second. Whatever it is going to fall at the same rate and hit the ground at the same time. This distance here from the center of the ball to the ground is -2 meters. And they set this up for you with the XY axis at the projectile here. All right, so we want to know how long the ball is in the air. So our goal here is to find the time. Let's list what we do know. Well, we know that VI is 6 meters per second. Now I ask you, is that positive or negative? Well, look at the direction that the arrow is pointing. Okay, so this would be a positive velocity because it is going up the y-axis. We also know that the displacement of the ball, that it's going to fall from here to the ground, is -2. So it's going to be -2 meters. I'll talk a lot more about that here in a second as well. And we also know that the acceleration, which is equal to gravity, is -9.81 meters per second squared. And that's a standard thing for gravity. So in all of your physics formulas that we've learned so far, you can replace A with G and delta X with delta Y, because these are going to be falling down the y-axis. I mean, you're going to be going down and up on these problems, these projectiles. So instead of going sideways, you're going up and down. All right. So let's find, and we also don't know VF. We don't know that either. So what we need to do is find the formula that does not involve time, and I'm sure you're very familiar with it, and it looks like this right here. It is VF squared equals VI squared plus 2G delta Y. Now normally that's 2A delta X, but in this free fall case here, it's 2G delta Y. And we can solve for VF. Okay? So we got VF squared, and that equals VI squared, which is positive 6 meters per second. And we're going to square that. Plus 2, and we got to keep our signs all straight here. We can't just ignore it. -9.81 meters per second squared times our delta Y, which is -2 meters. All right. Now, this is still VF squared over here. Doing a whole bunch of math, this will work out to be 36, and I'm going to leave the units off just for the sake of it being messy, plus 39.24. And that's going to be positive because it's a negative times a negative. When we add this all up, 36 plus 39.24 is 75.24. Now to solve this, we need to square root both sides. And so our VF would equal plus or minus. It's always plus or minus there, and then we have to figure out which one it is. 8.67. I probably could have called that 8.7 meters per second. So the final velocity when it hits the ground is 8.67 meters per second. Now, is this ball's speed going to be negative or positive? What do you guys think? Well, you got to know which direction it's going. The ball is basically going up, and then it's turning around and coming right back down. So its velocity is going in this direction right here with that arrowhead. So that's going to be a negative velocity. All right, so this is going to be -8. We're going to call it 8.7 meters per second, and that equals VF, final velocity. Well, congratulations, we found the final velocity, but we still don't know the time yet. So to find the time, I'm going to go back to a different formula, and we'll try to squeeze it in this slide here so we don't have to make another one. Vf equals Vi plus GT, G delta T. And what we're trying to find is delta T, but we have all this now. We have all this now. So I'm going to pause this, and I want you to try to solve this. Okay, I'll be right back. All right. So let's see. We're going to plug in negative 8.7. And our VI was positive 6 plus negative 9.81. Sorry, that's getting sloppy there. T. And we would subtract 6. I'm running out of space here, so bear with me. I'll conclude this over here. That would be negative 14.7 equals negative 9.81 t. And then we would divide both sides by 9.81, negative. And we would get a positive time, of course, of about 1.5 seconds. About 1.5 seconds. And the other thing to keep in mind that I just want to point out to you, if you launch something up in the air, and of course we're ignoring air resistance. So if I hit a ball in an airless world up in the air, it would go a lot higher. Okay, it would go, well, maybe not a volleyball, but it would certainly go higher without any wind holding it back on the way up or any friction forces. But on its way down, at that point, it would still be going 6 meters per second. It's the same up and down. That's important. But that's why, and keep in mind, that would be negative. This would be positive. This green arrow would be negative. But the reason why our final velocity is negative, actually I should have circled that one, negative 8.7, is the speed that it increases on the way down. So that's gaining a little bit more right there. So it's coming in fast and gains a little bit more on the way down. All right. Have a good one.